Okay, so this is a preview video for Unit 4, Objective 4, on Euler's number, which is known as the exponential. Okay, Euler's number is used in many biological growth applications, which we may do some of those next time, or in the next objective. But it is a very in higher level mathematics, it is used more than almost any other number. I want to show you the value of it, which you can get off your calculator, so I want to show you where you can access it. If you look down the far left-hand column where you see ln, right above it is e to the x. So if I just wanted to find the value of e, I'm going to do e to the first power, and I get e. So e is approximately 2.71828. And we're going to just go to 5 decimals. I'm not going to show where that comes from today, but at least show you what the value of that is. Okay? It is an irrational number. It never repeats. It may look like it repeats for a little segment here, but it does not. It is irrational, just like pi is, root 2 is. Okay, so what we're going to do just to start is to expand on our study of logs and exponentials. We are just going to go from exponential to log form. But when you see ln, that is log base e. Okay, you don't need to write log base e. We will just refer to it as natural log, and so the natural log of x means log base e of x. So in this case, it is not 10, it is base e. Okay, so we're going to go ahead and write each of these in exponential form. Okay, since this is natural log, it's base e. So what this means is e to the 2.303 power is approximately equal to 10. And we're now in exponential form. And just for giggles, if you do go ahead and you do e to the 2.303 power, it is pretty close to 10. Okay? The more digits we would have carried out, or I would have given you, the closer we would have gotten to exactly 10. Okay. All right, so the next one, we're going to put all these in exponential form. Since this is ln, this is base e, so this is e to the 4th is equal to x. And that's an exact value, and you could get this off the calculator also. All right, so the last one we're going to do is put this in an exponential form. So again, this is base e, so this would be e to the 5th is equal to x plus 3. So again, this just goes back to switching the forms. Okay? All right. So now we're going to go the other way, is given exponential form, we're going to put it into log form. Okay? All right, since it's e, it is log base e, but we're going to write that with an ln. So this would be the ln, so it's log base e of 10 is equal to x. Just that simple. Okay, this will be log base e, but I don't write it that way. I would write it as a natural log of 7.389. So approximately equal to 2. Okay, this is log base e. So what would this be? Is the natural log of 3 is equal to x plus 2. Okay, or x plus 4. I'm sorry. So we're not solving any of these. We're just flipping the forms like we've done many times already. Okay. All right. Now we're going to get on to solving some of these. Is how would I find this? And just like what we've done before, is if it's in exponential form, we're going to go to log form. Okay? So since this is base, just like what we did up here, since it's base e, it's not going to be log base e. I'm going to write it as a natural log of 10 is equal to x plus 2. All right. So we haven't done natural log. Well, it is ln. It's on your calculator. It's right here. Here's the log button. Here's the natural log. So all I'm going to do is a natural log of 10, and that is 2.303, which we've done it with other bases of logs before, is now approximately equal to x plus 2. So I'm going to subtract 2, and x is approximately equal to 0.303. Always we're going to round to just 3 decimal places. Okay? All right, so if you look at the second one here, all right, So we're going to put this into log. It is in exponential, so we're going to go to log form. Since it's base e, I'm going to write it as log base e, but I'm going to write it as a natural log, or ln, of 15 is equal to 2x plus 8. Okay, now I can go to my calculator and do ln, or natural log, of 15 is 2.708, and that's now approximately equal to 2x plus 8. Alright, so I'm going to subtract 8 from both sides, and as we've been doing, I'm just going to subtract 8 right here, and I get negative 5.292 is approximately equal to 2x, and if I divide that by 2, I'm simply going to get x is approximately equal to negative 2.646. Okay, again, that is an approximation. Here it was exact, here we switched to approximation. Yes, we could just solve it for x in terms of this without going to decimal values, but for now we're going to stick in this form. Okay? Alright, so now the last we did solving exponentials like we did before. We're going to solve some logs with natural logs. Okay, so we're going to do 3 of these. Okay, remember natural log, this is base e. So when I go to log form, this is not base 10, it's base e. This will be e squared, e to the second is equal to x plus 3. Now I can go get that approximation. So I'm going to do second. And then here's our e button. But what am I going to put here is to the second power. And what is that is 7.389 is now approximately equal to x plus 3. When I subtract 3 from that, I get x is approximately equal to 4.389. Okay? So in other words, if I plug in this, add 3 to it, take the log of it, I should get 2. Okay? Alright, so let's go ahead and do this one. So again, this is in log form. Doesn't matter which side the log is actually on. But this is base e, so this is going to be e to the 6.1 power is equal to 2x plus 10. That's not an approximation yet, that's an equals. So if I go to e to the 6th power, 6.1 power, that is 445.858 is approximately equal to 2x plus 10. So I'm going to subtract 10, and that's just going to be 435.858 is approximately equal to 2x. I'm going to divide it by 2. And if I divide that by 2, I get 217.929 is approximately equal to x. So that is the value that makes that true. If I would go check it, I'd multiply this by 2 and add 10, take the natural log of it, and I should get pretty close to 6.1. All right, last one. Can I have it equal to a negative number? Yes, because logs, as we've said, are the same as exponents. So this would be e to the negative 1st power is equal to x minus 5. Okay, so I'm going to do e to the, I'm going to put that in a parenthesis just for safe reasons. E to the negative 1 is 0.368 is approximately equal to x minus 5. When I add 5 to that, I'm going to get 5.368. And that's my answer. Okay? So relatively simple solve. Remember, if they're in log form, we go to exponential. If they were in exponential, we went to log form. And remember, when it's base e, we use the natural log, not base 10. Okay? So hopefully this gives you a good preview for when we start this in class next time. All right? Bring in your notes. You get extra credit for it. Thank you.